Hello, good morning, everyone. I have the honor to present you the first talk here at the PromCon. Well, my name is Niko. I'm from Runtastic, and together with my colleagues, I'm managing, maintaining, automating our production infrastructure at Runtastic. And I want to tell you some story about us, how we managed to migrate our monitoring to Prometheus from Nagios. Just as a quick overview of what the Runtastic infrastructure looks like. So basically, we are mostly open source driven, so we have a lot of open source technology in our production infrastructure, mostly Linux based, and we have a lot of virtualization at the moment, KVM based. At the moment, we have around 40,000 CPU cores, so 4,000 CPU cores, 20 terabytes of memory in total, and 100 terabytes of storage provided by our Ceph cluster. So all of them is managed by OpenNebula, and we have also some kind of databases here, MongoDB, MySQL, Cassandra, also RabbitMQ. So we have to take care of a lot of stuff, and therefore we also have to automate a lot of things. We have Cisco ACI for our data center networking, which we're also responsible of, and we use Chef for bootstrapping our machines and setting up all the servers. And we use Terraform for our infrastructure as code. In the past, at Runtastic, we grew a lot, so we had a lot of microservices. At the moment, we have 70 microservices live. And yeah, we had a lot of virtual machines to spawn up. And so also our monitoring had to scale a bit. But back in 2017, we started actually, when Runtastic started, we used Nagios in the past to maintain our infrastructure, to check our services, We have basic checks. We had basic checks for ICMP, for load. Disk space, as you can imagine, there's the 75% warning state and 90% critical state. So if you're familiar with Nagios, then this might be common for you. We also use and still use New Relic for the instrumentation of our applications. So also the crash rates, error rates, response times. And to be able to alert on that, when somebody of us is on call, we use Pingdom for that, which is an external service for doing external HTTP checks. And we also use Pingdom to force it to check specific Nagios service pages and with string matching. So if a service check in Nagios is being in warning or critical state, it would immediately send an SMS to the person that is being on call. It was horrible. So we used Chef for preparing all our Nagios setup, and here you can see a screenshot of our Chef data pack for adding new Nagios checks, basically. This is a configuration file, we would call it. It has 5,000 lines when we stop Nagios, basically. So if you created a new microservice, in this case, this are some MongoDB checks. You would have to add some MongoDB checks if there's a MongoDB in it. It was a mess. And it was an alert overflow. So here is a screenshot I made on a Sunday morning, where we usually have our rush hour in our production environments. Most of our customers are running on a Sunday morning. And the thing here is, as you might see, there are a lot of critical alerts. So this is only some of the critical alerts here, you see. And you might think that there's an issue in our production environment, but there was no issue, actually. So you see a lot of load alerts, for example. It was a total mess. And for a newbie here in our team, it was nearly impossible to find out if there is an issue in production. So this was unmaintainable anymore. So we sat together in 2018 in January, and we said, okay, we need to change this. There's no way to keep Nagios up and running like this. So we defined some goals, not binding ourselves to a specific tool. We just said on-call should be as comfortable as possible in the future. Also rethinking of how alerting should be done in the future. Is it really necessary to alert on specific things like high load or high network throughput? Is this really a thing you need to alert on, basically? And we also said, since we are a small team and we need to automate a lot of stuff, find a solution that is being automatable as much as possible. And also make use of graphs. So in Nagios, if you're familiar with that, it's not possible really to go back in time. So let's say you get the disk space alert, it's at 80% of disk space is full. Is it something you need to take care of immediately? Is it something that can wait 2 or 3 weeks? It was not possible to distinguish or predict if there is something going on in our infrastructure. So we wanted to go back in time and make some predictions. And also, yeah, it should be scalable and should be proof for future technologies, speaking about containers, for example. And so we started with Prometheus, our journey. So we picked up a microservice in production, and yeah, we also do some testing in production if necessary. And so we picked a microservice containing a lot of technologies, MongoDB, MySQL. This tux represents the node exporter. This was the first exporter we tested. We also wrote some custom exporters like New Relic or Sidekick, which is pretty easy, I have to say. And so we picked up some metrics and it went fine. So the next step was, let's spawn up our production Prometheus setup. So we just picked 2 bare metal servers. We still use 2 bare metal servers for it, running a total amount of 7.5 terabytes of storage. And right now we are able to keep 7 months of metrics. It's not super important to keep that 7 months, but it's always nice to go back in time and see in past events, for example, how specific metrics behaved in the past. Speaking about special events where more users are using our app. And we still use the internal storage of Prometheus. Now, speaking about the automation, which is a super important topic, we had some goals. Basically, roll out the exporters automatically. Well, we use Chef for preparing the virtual machines and setting all the servers up. So this was useful for us to use Chef for that. Service discovery. So in Nagios, we used Chef client for preparing all the checks, all the configuration files. And we said, there's no way we set up Prometheus like this and using a static list. So Nagios, Chef client was running on our Nagios system for, I think, 30 minutes in a total run. So we said, this is not a good way to do it. So we took a look at Consul. And what about the HTTP health checks? So in the past, we logged into Pingdom and configured a health check manually on the website. And since we're using Terraform a lot, it made sense to actually do this via Terraform. And the last point, add silences in the Alertmanager. So this was not on our agenda in the first place, but when you do a lot of automation and spawning up new microservices automatically, they are not ready for production yet. So someone has to do something here before it gets live. So when you create a new microservice, you immediately will fire some alerts. So it's mandatory for us to also create the silence when you prepare a new microservice upfront. Talking about Consul, it turned out we already use Consul in our production environment for our Terraform remote state. So if you work with Terraform in a team, then you have to pick you have to store the state somewhere. And so we said, it's fine. We can simply roll out the Consul agents on all the servers we want to monitor and use Chef for that. And also Chef should prepare one service definition for each exporter on each server. This is how the Consul user interface looks like. This is a sharing server 001 in that case. And you see here we have 3 services assigned to this Consul node. So we said for each exporter, create a separate service. And on the right side, you see here some tags in which I will come immediately. So when we worked with Prometheus, it was quite obvious that labels are quite important. And so we sat together again and defined what labels could be interesting for us to use. And therefore, it's also important to define what the use cases are, basically. So we could say, show me the load of all worker nodes of the newsfeed servers. So it could be interesting to have a service label. It could be interesting to have a role label. And the role label could contain, is it a server? Is it a worker? Is it an JProxy node? Is it a MongoDB node? Is it an Elasticsearch node? And we also introduced a hostname label to easily get the hostname out of it. We knew that there was the instance label, but using the hostname label was also quite interesting for us. And so we defined a JSON for Consul, basically to use to add the service to Consul. This is an example of the sharing server 001. Offering the MongoDB exporter. And we use these tags here, basically, tagging with Prometheus, so to tell Prometheus, hey, this is a Consul service that is relevant for you. And the other tags, so you cannot define key value pairs in Consul. So you have to do kind of a regex magic here to define your service labels, role label, service label, exporter label. This is how it looks like in Prometheus. So this is our job name POD that is used for all the things here. So we say here simply, which is in the documentation already, to keep everything that is labeled with Prometheus. And then The second regex here is where the magic happens basically. So everything that goes after the service string here that is being used as a target label service. And so it was finished so far. But what about external health checks? This was another great point because we used pingdom in the past and we said actually we don't need to use pingdom in future. We said we want to go with Blackbox exporter to do this. So we spawned up some EC2 instances. This was quite easy for us, and also to ensure that some Blackbox export is running in our office that has a direct connection to the data center, because there may be some services that are not reachable from the outside. You also want to check that. And it was quite nice because you check the HTTP response code and also get some metrics for the SSL certificate stuff. So you also have the checks for expiration, which is also important. Yeah, as we use Terraform a lot, it's quite easy to add a service, a health check in Consul. Surprise, surprise, it's the same company that provides Terraform and Consul. So this is an easy one. So just add a resource Consul service and add the tags that we saw in the past. But we use health check as a tag to indicate Prometheus, hey, this is a health check page that is needed by the Blackbox exporter. And we use a second tag here, URL. And there we can define a health check that is being used by the Blackbox exporter. This is how the job configuration of the Blackbox exporter looks like. Actually, what you do here is, and this is also documented in the Prometheus documentation, so actually everything that we needed to do was quite good documented in the Prometheus documentation. But we had to fiddle around with some regex here, also using the regex URL here, replacing it with the param tag. So this is something you need to find out immediately, but then you see that this is actually quite nice working. And the last one, which is super important, I have to say, it's adding the silence to the Alertmanager. If you do automation and you create new services via Terraform that are not deployed or not live yet, not ready yet, and producing some service down alerts all in the beginning, then add a silence. In our case, it is a quite simple solution. Just use the null resource object and use HM tool. Basically, so which HM tool you can easily add a silence. Actually, this would be also nice to have it as a Terraform provider. So this could be a nice thing here. And there you go, you're finished. So, I'm not getting any money for mentioning OpsGenie here. I have to clearly say that. We played around a bit with PagerDuty, OpsGenie, because we needed alerting at some point. So in the past, Pingdom did that for us, and we were abusing Pingdom a bit for that use case. So we said we need some kind of alerting. And our initial alerting plan was, so we have also some alerts with low priority. Of course, this would be a failed chef client run, for example, or something like, this space will get full in 4 hours alert. This would be also something that is low priority, that's informational for you, but not affecting our customers and not affecting any downtime or something like this. This would be used with the Slack integration. So we used the Slack integration a lot, actually. And alerts with high priority, which are on-call relevant, should get forwarded to OpsGenie. So if someone of us is on call, then OpsGenie should contact the on-call person via phone or via SMS. Then we sit together with the OpsGenie guys, and the question came up, why not forward all alerts basically to OpsGenie? Because OpsGenie is not only there for, and PagerDuty I think also not here only for alerting, for on-call, it's also here for alert management and incident management. And so we came up with 2 integrations. Basically, in OpsGenie, you define multiple integrations. It can be Prometheus, it can be Elasticsearch, it can be also New Relic. In that case, you can create multiple Prometheus integrations. And the easiest thing here is we have a Prometheus on-call integration where all the high priority alerts are forwarded to. And in that case, if an alert is received for this integration, call the pure ops guy that is being on-call. And also post some alerts to specific Slack channels. We also use Slack a lot to announce alerts. I usually call them stakeholder Slack channels because there are multiple members in this channel who are not part of the infrastructure team or maybe interested in some service outage. And we have the second one, the Prometheus Ops integration, which has a low priority alerts like the chef client failed runs. Notice that this this integration has the option disable notification. So you can set that in OpsGenie. If this option is set, then alerts forwarded to this integration are not forwarded to the on-call person. So there are no phone or SMS alerts. Then you don't want to wake up an ops guy in the middle of the night when the chef can't run fails. So this is something you have to take care of. So this is how you can integrate it with OpsGenie. And this is how it looks like in an Alertmanager configuration, quite simple. So we have two receivers here. What we do here is basically we distinguish when we define alerting rules and match with the on-call true label. So if you have an alerting rule that is important, then it's matched with the on-call true, then it's on-call relevant. Notice also the group by ... here, which I will come to later on. So this is how the receiver basically looks like. It looks like a bit like a mess, but what we actually do here is in the description, we prepare the Slack message. So we are able to also add dashboard links if necessary, or runbook links, you could also do this. So this would be then quite easy to implement. So why we use group by ... I think this was integrated 6 months ago or something like this. We had major issues with OpsGenie in the beginning because of the alert that the deduplication OpsGenie does. So when you forward alerts to OpsGenie, it also does some kind of grouping of alerts. So if you have, imagine the chef can't fail to run alerts is being sent to OpsGenie for the host name sharing server 001. Okay, OpsGenie creates an alert of it, alerts via Slack, but 5 minutes later, another server, the sharing server 002, has the same issue, the alert manager sends the alert to OpsGenie, and OpsGenie then says, hey, I already received this alert for server 001, but anyways, I don't create a new alert out of it. So it was important for us to use this group by then. OpsGenie also creates dedicated alerts for different chef can't fail runs. So this is a kind of grouping you have to take care of, not that you overlook alerts in that particular case. This would be an example alerting rule for on-call alerts. So basically, this is from the Blackbox exporter. What happens if a service goes down? So then you have the label on-call true that indicates, okay, this is on-call relevant. If the service is down, immediately fire up and send out alerts to the on-call persons. And this would be an example alerting for low priority alert. I call them also informational alerts. Basically, this is nothing super critical. In that case, it is a MongoDB relevant metric that indicates that there may be some issues with some queries being running on the MongoDB itself. This could be interesting for you as an infrastructure or database engineer, but it's not relevant really for on-call. And you also see that we added a dashboard link to our Grafana instance. So if you want to check that, this could be also interesting to see in a Slack message. And this is actually how a Slack message looks like. In our case, we have for our Cisco ACI networking, we have an alert here. This is coming from a dedicated exporter we had to write. And the nice thing here in using alert management via Slack is you can easily acknowledge alerts and tell your team colleagues, hey, I'm working on that alert. And also it's easy for you to add notes so that everyone is aware of what the issue is about. This is a minor alert, by the way, so this is nothing super critical. Heartbeat. It's also called Deadman Switch. So this was actually the reason why we chose OpsGenie, because sending the alerts to a dedicated third-party provider is nice, but what if Prometheus itself is down? What if our data center uplink is down? What if our networking is down? So there's no really a check if the monitoring itself is up. So the heartbeat is actually quite simple. So you just use the vector 1, for example, a fake alerting rule that OpsGenie expects from you every 5 minutes. And if this is not received, then OpsGenie immediately fires an alert, also an on-call relevant alert, saying, hey, I didn't receive the heartbeat. And this is how it looks like in the Alertmanager configuration. So we match with the heartbeat label, basically. And this is a bit different. This is just a simple webhook that you are calling the OpsGenie API. And you use your API key from OpsGenie as a basic auth, basically. And then this is up and running and working. CI/CD pipeline. So also speaking about a bit of the automation. So as you can imagine, we use Chef a lot. So of initial version of rolling out Prometheus itself was using Chef for that. And also our alerting rules were put via cookbook file resource directly on the Prometheus servers. But then other departments came to us saying, hey, this is super nice. We want also to have some custom alerting rules and recording rules. And we said, oh, this is not really possible at the moment. So we sat together again and we said, why shouldn't we put all the alerting and recording rules into the Git repository? And maybe we have the chance to automatically test it for syntax errors or maybe unit tests and deploy the master branch on all Prometheus servers basically. And as soon as a merge to the master happens, the alerting rules are automatically pushed to all Prometheus servers. And this is how it basically works. Basically, we set up a Jenkins instance that does nothing else than running prompt tool against each YAML file that is in the branch. And then Bitbucket is what we use for our Git repositories. Bitbucket is sending HTTP calls to each Prometheus server as soon as the master branch changes. So this is nice, but there is something missing here. So as soon as someone has to deal with the HTTP call on the Prometheus server, so we had to write a Ruby-based HTTP handler that is running on each Prometheus server, accepting those HTTP call from Bitbucket. And when this HTTP call is received, a Git pull is initiated, and then a Prometheus reload is done. So not a restart, because a restart takes up to 20 minutes in our setup, but the reload will do the thing for you. And this is how it looks like when you're developing recording rules or alerting rules. I work here in a wrong alerting rules branch, and you see the build failed actually. So you can directly see, okay, there's a syntax error in it. If you click on it, then you would see the output of the prompt tool and saying there is a syntax error in YAML file hproxy YAML, for example. And this is how you basically, when you create a new pull request, you directly get the feedback also if the syntax is fine for you. And this is the most critical thing if the alerting rule are wrong in some case, and then you are not updating your alerting rules anymore. So we had that situation already. That's why we decided to go with the CI/CD pipeline. All right, I know I could tackle a lot of things here. So also speaking about specific alerting rules, yeah, time is rare. So if you have any questions, if you have any feedback, you saw maybe something you found something nasty here, feel free to approach me. And feel free also to write me an email if you're watching this on a live stream or seeing the recording here. Feel free to ask me some questions regarding our setup. Thank you.
All right. Thank you very much. We actually do have some time for questions, like 5 to 10 minutes, if anyone has any. I'll throw this over. Careful. 1, 2. Okay. So what happened to Nagios? Could you completely shut it down, or are you still using it?
Actually, yes. There are some pitfalls. That is actually a good question. That brings me to some topics. There are some special cases, some special checks, like cron shop checks, or is it a disk space check you're a bit worried about? But actually, we managed to do this using the text file exporter a lot. So the text file collector itself. So we rolled out the node exporter on each server. And we really tried to add metrics to Prometheus itself to get rid of Nagios, basically. But this also means for you that you need to remove a lot of alerting rules. And this is also a bit of changing your alerting strategy. So in Nagios, you would really add a lot of checks, a lot of alerts, which is totally useless because everyone did it like this in the past. So this is the thing that you really have to think of. What is really necessary or worth an alert, basically? Is it really necessary to alert on load, or is it really necessary to alert on high network throughput? This is something you have to decide. But yeah, we got rid of it, yeah. Hopefully and thankfully.
Hey, do you use SAMP Federation or Thanos? Do you have high availability for Prometheus?
We do have 2 instances running separately. Grafana is running in a J mode. That is basically all we have. So if both Prometheus server would be shutting down, then the heartbeat would fire up in that case. But the instances are running separately. This is quite nice. Also, the Alertmanager, you can easily create a mesh network. So there is no magic behind it, no need for setting up a pacemaker setup or something like this. So it's actually quite nice to scale. Does that answer your question?
Hi. Can you a little bit elaborate on the exporter for Cisco ACI infrastructure?
You're using Cisco ACI?
Yes.
Yes, we can. Feel free to approach me afterwards. I can show you the code I used to call Cisco SCI. But basically, to sum it up, we only grabbed the health score of each leaf switch, of each spine switch from the fabric. And for more details, you have to go to the Cisco SCI web interface or just check the vaults occurring there. If you're interested in that and how we automated also the Terraform stuff, we can talk afterwards if you like.
Yeah, thanks.
Oh.
Hello. I'm wondering with the rules CI/CD whether the prom tool was accurate or whether that was enough so that you always end up with a working Prometheus instance after that's integrated.
No.
Okay.
This is a nice question. Yes, you're definitely right. So this is not the final solution. So I think we already have the unit testing, thankfully. So actually, it's quite hard to also, if you change the Alertmanager configuration, to test the routing of the alerts. So what I do here basically is testing it manually by firing an alert, but this is not a perfect solution. So we're still working and finding a solution to test alerting rules and also changing stuff in the Alertmanager configuration, because this is getting more and more important. And if you break something here before a Friday, for example, then on-call would be a bit, maybe not so noisy, but not very helpful. Did you do something in that direction, testing, unit testing?
So far, I have just done Consul like you.
So it's the same approach right now. Okay. But maybe come up with some better solution in the future.
Cool. I'm wondering if you could speak about the Slack integration a little bit more. I'm wondering if you're handling like external webhooks or something, or if you're spun up a microservice in EC2 or something to handle that.
You mean how we forward the alerts from OpsGenie to Slack?
Yes. Is that built into OpsGenie or?
Yes. So basically, in the past, at the beginning, we used the Slack integration directly in the Alertmanager, but then we decided to use OpsGenie for that. So OpsGenie receives all alerts, and in OpsGenie you can find alert routing and create multiple Slack channels, Slack integrations. This is all super fine handled with OpsGenie. And yeah, for the stakeholder accounts, you can really define which kind of alerts, which string matching do I need to post an alert in this channel, for example. I can show you some configurations afterwards if you're interested in that.
Yeah, I'll come find you.
It's quite easy to set up.
Any more questions? Oh yeah, back there. Okay, one more. Yeah.
You told that the Sunday morning, for example, you have a lot of upload of people running. Do you have some sort of behavioral alerts? So you must have mainly the weekend a lot of traffic.
You mean if there are some alerts that are expected?
Based on the day of the week, or yeah.
Actually, some of them. So if there's really a lot of traffic, we knew, for example, that RabbitMQ. And this is also interesting, RabbitMQ exporter, for example, that is directly connecting to the RabbitMQ web user interface. This has low priority to RabbitMQ. So if there's high load on RabbitMQ itself, then the exporter is not able to connect to the UI anymore because of low priority. And this means basically that you don't have any metrics, and we say, okay, RabbitMQ is down, so the exporters are down, but actually RabbitMQ is working. So this is some kind of expected behavior that we see, okay, RabbitMQ is on a high load. We managed to do this by prioritizing the UI for the export, but I hope to get export integration for RabbitMQ in the newest version so that it's directly integrated. But yeah, actually we don't have any false positives since we use Prometheus, but this is also some kind of sticking to your alerting strategy and really be hard with defining alerting rules. So only fire alerts if this is really necessary. That was our goal, and we somehow managed to do this. Still, we have some disk space. Disk will get full in 4 hours. Thing is, because of Log4j getting full, cron jobs are running that do some magic on the servers, basically. So this is still something that pops up. So the disk space will get full in 4 hours, basically. But this is actually a nice alert you can read in the robust perception block. That is a perfect example of what Prometheus is capable of with doing predictions, basically.
All right, we have one last question here. Sorry, and could Adam already come up to plug in?
Hi, thank you for your talk. How much memory do the servers that you run Prometheus have? And how many time series are you managing right now? And do you have any contingency plan for when that service cannot handle all those time series?
At the moment, yes, for our use case. We have 32 gigs of memory on each server at the moment, which is, I think, for the amount of data we have, not that much. I cannot really say how much metrics we are currently having there. I think we're ingesting 200K of metrics per minute. So we have more than 5,500 exporters currently integrated into Prometheus. It is fine for doing alerting and for analyzing in Grafana, but as soon as you do some data analytics, how many CPU cores are used by time or something like this, if you need to go back 7 months, then it is really hard. Then CPU usage is rising. So CPU usage is the most problem here. And we also had to use the query timeout thing here. So a query is being killed after 16 seconds because Grafana is used by many employees now, and not all of them know that using specific queries can kill Prometheus. So make sure that you set the timeout on the Prometheus server to at least 60 seconds or something. But yeah, we need to find a solution in future, maybe using an external storage for high load queries. Does that answer your question? All right.
Cool. Thank you very much.